Hi, Dr. Revis here with Watch Me Work It. Let's talk about how to do charges on Lewis structures. Watch me work it. What are the charges on each atom and their overall charge on each molecule? When we do charges, there are two ways to do it. One is by the standard formula, charges equals valence electrons, formula shown here. Charge equals valence electrons minus lone pair, minus 1/2 the bonding electrons. Or you can do it by what I call the quick count method, which just changes the math a little bit, that's all. In this case, just take a look at the valence electrons. That's how many you should have, minus the ones that are attached. That's how many you have, and that gives you the charge. All right. I typically use the quick count method, but either method works. So let's do some problems here. First thing we're going to do is split the bonds here so we can only count the electrons associated directly attached and associated with each atom. So let's do the central atom, which is very popular to do. In this case, we know that sulfur is located in group 16, therefore it should have 6 valence electrons. So those are your valence electrons. We'll do this a couple of ways. Minus the number associated with it, we have 2 lone pair on the top, 2 on the right side, 1 down on the bottom and 1 on the left. So we just count around here. 1, 2, 3, 4, 5, 6 minus 6 gives 0. Therefore, the charge on sulfur is 0. Do likewise with hydrogen. Hydrogen should have 1 valence electron, and the number it has associated with it is 1 electron because this is one dot there. Remember that one line equals 2 dots, so this gives 0 as well. Other hydrogen is the same, so it's going to be 0. Let's do another one here. Let's just split these in half so we only count the electrons we really want to take a look at associated with boron. Boron is in group 13. Therefore, it should have 3 valence electrons minus the number of electrons directly attached to it, 3, and that gives us a 0 for the charge on boron as well. So boron has a 0 charge. These hydrogens look like what I just calculated. Calculate the same way, you'll get a 0 charge. So let's just go ahead and do chlorine here. So chlorine, group 17, therefore it should have 7 valence electrons minus the number of electrons directly attached, 2, 4, 6, 7, because half of that line belongs to it. So that's 7, and that gives us 0. So we have a lot of zeros here. By the way, I should go back and tell you that the overall charge on the first one, on this compound, is overall 0 because it's 0 plus 0 plus 0 equals 0 for the overall compound charge for this compound here, the boron compound. We have 0 plus 0 plus 0. Again, overall charge of 0. Get all zeros here, which is absolutely fine. Let's go to the next compound here. We'll break these in half. Count the electrons on carbon. 1, 2, 3, 4. Carbon should have 4. Minus 4 gives me an overall charge of 0 on carbon. Hydrogen, we've seen this before, so these are all zeros. You can do the calcs and you see the same thing. Here, oxygen should have 6 minus 2, 4, 5, 6. Minus 6 gives me 0. Each atom has 0 overall, 0 charge on that one as well. Next one up, let's do here. Split these in half. So nitrogen here, 1, 2, 3, 4, 5. It should have 5, minus 5, and we get a 0 here. So nitrogen has a charge of 0 on it. The oxygen on the left has 2, 4, 6. 6 valence electrons it should have. It has 6, so minus 6. Dots associated with it directly attached is 0. The oxygen on the right side should be 6, and that's going to be, it has 2, 4, 6, 7, minus 7. This gives it a minus 1. So overall, so the charge on the oxygen on the right is minus 1. The overall charge is 0. I'll just write this out if I can somewhere. 0 plus 0. Let's do that again. 0 plus 0 minus 1. That's what I should be writing next. Minus 1 gives an overall charge here of minus 1. I think you can see that math. 0 plus minus 1 plus 0 gives you minus 1. So that's the charge there. All right, let's do some other ones. Let's take a look at this next one up, the gallium compound. Split these in half. I'm going to forego the hydrogen since you've already seen those. You've seen this before, so those are going to be 0. Gallium, located in group 13, should have 3 electrons, but associated with it, gallium has 1, 2, 3, 4. That's -4. Gallium in this case has a -1 charge on it. Chlorine. Chlorine should have 7 based on its valence electron count. Associated with it right now, it has 6. So this is 7 minus 6 gives a +1. I always like to write the plus signs with it, just to keep an eye on them. So gallium has a -1 and chlorine has a +1. But the overall charge on this molecule is +1 -1 equals 0 overall, because it is 1 minus 1 equals 0. Okay, let's move on to the next one here. Split these in half. I'm going to let this hydrogen go because we've seen it before. I'm going to also let this oxygen go. Well, why not? Let's just do the oxygen anyway. The oxygen on the top is 6 valence electrons. -6 gives me a 0 here. The sulfur on the left, 6 valence electrons because it's in group 16. 2, 4, 6 electrons associated here. -6 gives me a 0 here. Carbon in the middle here, carbon should have 4. It has a rounded 1, 2, 3, 4, 5, -5 here. And so that gives me carbon with a -1. So the overall charge on this would be a -1 because we have 0 plus 0. So we have 0 plus 0 plus 0 -1 for an overall charge of -1 for this molecule, -1. There we go. Let's do the one here. Other compound, you've seen these hydrogens before, so we're just going to forego them. We've done it already. Fluorine here, 1, 2, 3, 4, 5, 6. It should be 7 minus, and it's -6 because it has 6 associated with it. So here, 7 minus 6 gives me a +1. Carbon here has a 1, should have 4, and it has 1, 2, 3, 4, 5, -5. That's a 5. Okay, I'll write it a little cleaner. -5 equals -1. So the overall charge of 1 and a -1, overall charge of 0 on this molecule here. Okay, just clean that up just a little bit for you. 0, because it's 1 minus 1, 0. Right here, we have this one, split these in half. And so we have hydrogen we've seen before, hydrogen we've seen before. Let's do the chlorine. So chlorine should have 7, because it's in group 17, 7 valence electrons. -6 associated with it. We can count them 1, 2, 3, 4, 5, 6. And that gives us a +1 on chlorine. Phosphorus is in group 15, should have 5. Associated with it, it has 1, 2, 3, 4, 5, 6. -6 gives us a -1. So this means an overall charge of 0. -1 plus 1 gives me a 0. All right. And so that's how we determine the charges on Lewis structures.